look at is how we can use trigonometry to help make a formula for finding the area of a non-right angled triangle. Something like this. The first thing we've got to do is work on a convention for naming the different sides and the different angles of the triangle. And although when we're doing geometry, we're really careful and clear about how we label angles, we can afford to be just a little bit simpler when we're doing this kind of thing, and we can label them something like the angles A, B and C, and then we're going to just label the sides with the same letters. We're going to use lowercase letters instead, and we're going to match the angle with the opposite side. So if this is an A, then this is side A. If this is a B, this is side B. And if this is angle C, this is side C. And so now we've got the sides and the angles labelled. What we're interested in is building an equation for calculating the area of a triangle. So we're going to start off by reminding ourselves that the area of a triangle is always half of the base times the height. If we look at this sort of triangle as an example, the base is really easy. That's already the B there. What's difficult, though, is the height. That blue dotty line there is the height of the triangle. We don't know how much that is, but what we could do is break off part of that triangle like that, and that's going to show us that we can calculate the height using trigonometry. And the rule that we can see is that the H is on the opposite side, the A is on the hypotenuse, and we don't know anything about the adjacent. The O and the H means that it's going to be the sin function, so sin theta is O over H. The O, the height, the O is H sin theta, and so the O, which is the height, is what we can substitute in up here as the H. We're going to rewrite it though with the symbols from our triangle. So O is A sin C. So when we come to write the area, we're going to plug that in for the height. So area is B A sin theta over 2. You'll see that written as AB sine theta over 2. And so what we've come up with is an equation for finding the area of a non-right angled triangle when we know two of the sides and the angle. And if you come back to this triangle here, you can see that the two sides that we know are always the two sides on each side of the angle that we know. They're both sides that are adjacent to the angle that we know. Let's do a quick example. Okay, so here's an example. A non-right angled triangle, one side 10 centimetres, one side 14 centimetres, and an angle between them of 30 degrees. We're just going to plug those numbers into our equation. So there's our equation. Area is AB sin C over 2. Plug the numbers in. 10 times 14 times sine 30 over 2. It actually turns out when you use sine 30, it's not too bad to do in your head. Sine 30 is a half. And so half of 14 is 7. So we're doing 10 times 7 is 70. And then half of 70, 35 centimetres squared because it's area. Just like that, we can use trigonometry to calculate the area of a non-right angled triangle.